Welcome to lecture 20, our last lecture. In this lecture, we would review some EIGRP related concepts and configurations. Therefore, after this lecture, I expect you to be able to configure EIGRP key values, configure offset lists, configure bandwidth percent, configure split horizon, and describe stack inactive routes and infinite number. Let's start our today's mission. I'm sure you remember that EIGRP has a formula for metric calculation, and this formula contains some k values from k1 to k6. k1 to k5 are configurable through command prompt now. It was in lecture 11 that I show you how to manipulate EIGRP metric calculation by changing bandwidth and delay on interfaces. And now we want to see how could we change these k values and manipulate this formula. As you remember that k1 and k3 by default are 1 and other ones are 0. And if you decide to change these values, you have to configure them with the metric weights command, which is done in router subcommand mode. You have to enter subcommand mode with router EIGRP1, for example, or with named EIGRP, or in IPv6 configuration in config-rtr, and then issue the metric weights command. After metric weights, you have to enter type of service, which is now only support 0, and the number that you could enter is only 0. The range is 0 through 8, but the only number is supported is 0, and then enter the k values from 0 to 255. If I want to show you this command, when we enter global configuration mode with config t or configure terminal command, we could issue router EIGRP1, for example, for IPv4 routing, and here we issue metric weights. As you could see, the type of service values could be from 0 to 8, but only TOS 0 supported, so we could only put 0 here, and after that we could configure K1, which is from 0 to 255. For example, I put it 1, and then K2 from 0 to 255, K3, K4, and K5, and you push enter, and these values will consider in EIGRP calculations. And we could do it for IPv6 too. For example, if I issue IPv6 router EIGRP1, and here say metric weights, and again type of service and K values. This configuration could be done through named EIGRP2. In this way, you could configure k values and manipulate this formula, but I strongly recommended that do not change these values, and this is, I think, Cisco's recommendation too. Offset list is another tool for manipulating EIGRP metrics. With offset list, you add a value, which is called an offset, to the calculated metric for a specific route. So you choose a route and then tell the router to add this value for this route. But how could we choose the specific route? By writing an ACL. So to specify our route, we first have to write an ACL with permit situation. We could specify the prefix and the prefix length both, and then match it with that specific route that we want to add the offset value to it. And then we could match the direction of the route. We could tell the router when this route comes to this interface or goes out this interface, add this value to the metric which is calculated. So we could match the interface too. And the final tip is you could add this offset for both visible distance and the reported distance. The command for setting the offset list is offset list, and then access list number or access list name, then in or out, mean when the route comes to the router or when the route goes out from the router, and the offset number, the value which you want to add to the metric, and then you could specify which interface you want to add this value. Let's configure a simple example to show you how this offset list could manipulate your EIGRP metric calculation. I choose a very simple scenario. We have 3 networks, 192 168.1.0, 2.0, and 3.0. I just configure the interfaces and the IP addresses, and now I want to configure EIGRP on these routers. So I go to router 1 and say router EIGRP 1 network 192.168.1.0 with this configuration, and network 192.168.2.0 and this wildcard mask and no auto summary. In router 2, router EIGRP 1 network 192.168.2.0 with this wildcard mask and 3.0 with the same wildcard mask and no auto summary. As you could see, neighborship is formed between these routers, and now I expect to know about the route 192.168.1.0 from EIGRP. As you could see, the calculated metric is this, and now I want to show you how could we change this calculated metric. Remember, this is 30720. And now let's clear our screen and say offset list. First, we have to write an access list to match the route. So I go to access list 1, permit 192.168.1.0, and then router EIGRP 1 and say offset list and access list number here. And then in or out, in router 1, I have to add the value when the route goes out from interface fast Ethernet 0/0. So I say out, and the offset list number, for example, I plus, what was it? It was, I put 4 just to show you. And then interface fast Ethernet 0/0. Offset list, the access list number out, I mean when this route wants to go out, and then the added value, the offset number, and then fast Ethernet 0/0. As you could see, route configuration changed, and here I expect to have another value for this route. Let's see it's applied or not. Again, show IP route. As you could see, the number 4 is added to this value. In this way, with offset lists, you could change your metrics, which is calculated by EIGRP. By default, EIGRP uses up to 50% of the defined bandwidth on the specified interface. This could not be a problem when you have high bandwidth interfaces, for example, when you have fast Ethernet, gigabit Ethernet, or even 10 gigabit Ethernet for T or 100 gigabit Ethernet interfaces. But when you have low bandwidth, especially WAN interfaces, for example, you use frame relay, which is non-broadcast multi-access network, which means that you could not broadcast layer 2 information, so per VC or per virtual circuit, EIGRP should make a copy of the advertisement or any other packets and send it on each PVC or permanent virtual circuit. And if EIGRP uses 50% of the bandwidth, it may cause some problems for your bandwidth, or at least you use 50% of your network capacity for EIGRP, and your network may become slow and your users may complain. So we could configure this percentage usage on the specified interfaces. For example, if you have low bandwidth interfaces such as frame relay or any other WAN connections, you could go to interface you want or the sub interface and say IP bandwidth percent, EIGRP, your AS number, and the percentage that you want to configure. If I want to show you this, I just turn on a router, and inside an interface, there is no matter which interface, the interface that you want to do this configuration, and say IP bandwidth percent and the EIGRP and your AS number and the percent that you want to assign EIGRP to use the bandwidth of this interface. In this way, when the interface does not have enough capacity for sending EIGRP, queue the EIGRP packets and then send them with a delay to the neighbor router. There is a rule which is called split horizon in distance vector routing protocols, which could help them to prevent routing loops. Split horizon rule is very simple. A route learned on one interface should not advertise back out of that same interface because it may cause routing loops. This rule is very good, but in some situations may cause some problems. For example, in a frame relay cloud network. As you know that we could configure frame relay sub-interfaces point-to-point and point-to-multipoint. Consider a situation that we configure multi-point. I mean, we have two PVCs from this router to the branches. These are PVCs, and this sub-interface is a multi-point sub-interface, and all of these PVCs has the same subnet. Although all of these are in the same subnet, these routers could not become neighbors because they do not have direct layer 2 connections. This is a minor problem. Split horizon caused some problems here for us. Consider this router has a network like 192.168.3.0 here and advertise it, and this router, let me call it headquarter and call this branch 1 and branch 2. When branch 1 router advertises the network 3.0 on this interface, headquarter router receive it on some interface, for example serial 0/0.1, which is in multi-point position. The split horizon, which is enabled by default, tells the headquarter router do not advertise this route on this interface again. In this way, branch 2 could not learn this route because headquarter does not advertise it on this interface. This is the same interface that branch 1 and branch 2 are connected to this. Therefore, headquarter do not advertise network 3.0 to branch 2 router because of split horizon. But how could we solve this problem? The answer is very simple. You have to disable IP split horizon feature. This feature is configured on sub-interfaces. IP split horizon EIGRP the AS number. This command is issued by default, and if you want to disable it, you have to put a no in front of this command, and in this way the split horizon feature is disabled on this sub-interface, and after that branch 2 router could learn the routes which are reachable from branch 1 router and vice versa. What is stock inactive? Consider a network like this and extend it with other routers that I do not draw them here. Assume that in router 1 a route fails and there is no any feasible successor route. The dual algorithm tells the router 1, now you have to ask your neighbors if they could help you to reach the failed route. So router 1 sent some queries to router 2 and router 3 and put the status of the route for the failed route from passive to active. As you remember that when we issue show IP EIGRP topology, when the routes are in passive mode, we say that it is good because it means that router passively searches for them, and it means router does not search for them. And when the routes are in active status, it means that router actively searches for them. Now router 1 put the status of the failed route inactive. It means I actively searches for this route. If router 2 and router 3 does not know about the failed route, they ask the neighboring routers themselves. And this query could propagate to all of the routers in the network. But how long router 1 should wait for the reply? By default, router 1 waits for 3 minutes. And if router 1 does not receive reply messages from router 3 and router 2, the failed route goes to stock inactive status, SIA. But what would routers do when the route goes to stock inactive status? It depends on your iOS situations. In iOS before 12.2, routers break down the neighborship of that router. I mean, for example, if router 1 answers the query and says, sorry, I couldn't guide you to this network, but router 3 does not reply, router 1 thinks that the router 3 is not a good neighbor and break down the neighborship with the router 3. It is an aggressive action, but the routers with the iOS before 12.2 does this and break down their neighborship. In the routers that have the iOS after 12.2, when this timer becomes half, for example, if it is 3 minutes, in 90 seconds, router sends a query which is called SIA query. It means that I'm still waiting for your response. And router 3 reply it with a SIA reply. It means that I'm still querying for your query and I'm still waiting for my neighboring routers. Wait till I answer you. If the router sends the SIA reply, router 1 does not break down the neighborship and wait until query reply back. But if the router does not send any SIA reply also, then the router breaks down the neighborship and tells that this could not be a neighbor of mine anymore. So remember that before 12.2, in any way, routers break down the neighborship when a route goes to stock inactive routes, and all of the routes which are reachable from these routers are deleted from the routing table. But in routers that they have the 12.2 and after that iOS, first the router sends a SIA query in the half of the stock inactive timer, and the neighboring router will reply the query, and if it replies the query, the routers wait, and if it is not answered with SIA reply after finishing the timer, then the router breaks down the neighborship with the specified router. If you want to change this 3 minutes default value for stock inactive timer, you should go to router subcommand mode and issue the command timers active time, the time that you want, and the time is configured in terms of minutes. You could configure the time other than 3 minutes if you want. Infinite number or infinite metrics. In a normal situation, for example, think that there is a network which is connected to router 1 and it is the network of 192.168.1.0, and this router advertises to others that you could reach this network from me with this reported distance, as you remember from EIGRP process. But assume that this network is failed and this connection is broke down. Now router 1 has to advertise to the other routers and tells them that you could not connect to these networks from me anymore. Think about it yourself and find another way to reach this network. But how could router 1 do this and tells the other routers that you could not connect to these networks via me anymore? This advertisement is just like the other advertisement. The only thing that is changed is the distance or the metric. In any dynamic routing protocols, there is a number which is called infinite metric or infinite number. When a router put that value in the metric field of a route and advertise it to other routers knows that this router could not connect them to the specified route anymore. So when the network of 192.168.1.0 is fed in router 1 advertises this route and tells 192.168.1.0 with the specified subnet mask is reachable from me, but with the infinite metric, which is 2 power 32 minus 1 in EIGRP, and put this number in the metric field. And when this router receives this advertisement, understand that this router could not connect it to the specified network. So this router searches for other options like feasible successor route or query response process that we talked about it before. Now it's summary time. In this lecture, we learn how to manipulate EIGRP metric calculation with changing K values and setting offset lists. We say that how we could limit the bandwidth usage of EIGRP for sending updates. We understand what is split horizon rule and how we could disable it in some situations. We learned that what is stuck inactive situations in some routes and how could we deal with it, and what is the infinite number in EIGRP. This is our last lecture. At the end, again, I ask you, I really beg you to send me the feedbacks and help me to improve my courses. I hope this course helps you to improve your knowledge, and see you in my next courses. Thank you for watching me.